All right, thank you everybody for joining. We'll give a couple more seconds for people to settle in. While people are settling in, I'll just do a quick intro for myself and my co-speaker today. So my name is Shiv Trisal. I'm with Databricks. I head up our global manufacturing and energy industry go-to-market strategy here, and super excited to welcome you all to our webinar on AI-driven digital twins with our partner DataSentics, where we'll be unpacking a lot of trends around this space, what we're learning from so many different customers that I work with in the industry, and also take some specific examples and case studies of real world use cases and customers that we've worked with with our partner DataSentics. So excited to share all this amazing content that we have together. Let's give another few seconds here for people to get settled. All right, seems like we're on time. All right, so super excited. So we're going to talk through, about 15 minutes or so. I'm going to be covering some of the trends that I'm seeing in the industry, and then I'll hand it over to Martin from DataSentics. We'll also go through a round of introductions on his side and cover some of the content and the work that they're doing with Databricks technology for real-world customers in the connected product space. So I'll start off by saying, first of all, we have to make a distinction about manufacturing as a function versus manufacturing as an industry. So when you think about the industry today, most people think of manufacturing as production, and a lot of the association as a result comes to thinking about turning wrenches. Well, it is in some degree about that, but it is also about designing products faster. It's about producing products faster. It's about marketing them in a better way. It is about servicing the installed base in a very different way, given the advent of all of the technology that's happening in the space of autonomy and connectivity, which is shaping a future of smarter products, products that we interact with as consumers on a day-to-day basis. So think about your car, think about your smartphone. And I think there's no other better way of expressing what a transformative stage this industry is in with respect to autonomy and connectivity than Jim Farley's statement, who's the CEO of Ford, thinking about how building vehicles is now more like building smartphones. And right now, and this is very representative of where the industry is, not just at Ford, is about changing the way consumers or end consumers actually interact with these products and the experience that they get out of interacting with these tangible products. And it's all about how the smartphone industry revolutionized the way people thought about calling each other and connecting with other people. The same thing is happening across many different industries in manufacturing, not just in automotive, but in every element or every corner of the industry where there is tons of connectivity and now more and more connected products taking shape. So the way to think about it, and what I see in every corner of the industry, with over 2,000 customers that we see and work with on data analytics, generative AI projects, particularly related to connected products data, we see again and again the one common theme is that every product in every company is now treated as a software product. And that has major implications in how you manage data and how you create value from it. So one thing is very, very clear, and we've analyzed a number of studies and number of companies' financial performance. Companies that do a better job of monetizing their connected product data. And I'm talking about data that's streaming in from their products, operating all over the world, and making sense of that data and monetizing it has a disproportionate impact on value creation. You would ask how. So let me give you some proof points on that. If you look at the investor community on Wall Street or anywhere else in the world, in terms of how analysts and investors and people in the financial community value these businesses, they value every dollar of revenue that's coming out of this new way of creating value, which is using data from your installed base, applying some level of novel analytics and AI and machine learning techniques on it, and creating new sources of value. Every dollar of revenue that's created as a result of that business model is valued 4 times higher than any other legacy business model of selling the primary unit of production. And I think that's a very, very compelling reason for companies to go and keep investing in transitioning their business models to more data-driven, more connectivity-driven services. Second aspect of it is it's much more profitable to be service-oriented in the first place. So if you look at profit margin of services versus new equipment sales, it's about 150% higher. And last but not the least, this ability to monetize connected products data really opens up tons of new addressable markets for these companies that are way beyond the primary unit of production. And in some cases, we've seen this number to be north of over $100 billion in terms of the services that are created and the value that can be captured as a result of thinking beyond the primary unit of production, which is the next vehicle, the next smartphone, the next device, or the next airplane, right? So really thinking about it from the perspective of the full life cycle of the product. How do you create new sources of advantage and new sources of value for your customers that can help you unlock broader markets that you did not otherwise have access to? Now, the reality of telemetry data, which is created on products, is very simply put in 2 ways. One, product telemetry data is noisy, it's complex, but it's super high value in your ability to actually go personalize any experiences for the customers, to be able to understand how your products are performing in order for you to really enrich everything you're learning about how the products are being used how the customers are using your products and how they're being deployed out in the field, and really drive better decisions in your operations and fulfillment and how you're actually managing your supply chain to go deliver on the promise to your customers. And it's not just limited to the 4 walls of the company. It's also now increasingly being shaped by how you share these data sets and that you're collecting from your fleet of installed base and your connected products with even external parties. So what I mean by that is, we see examples of this in the automotive industry quite a bit, where you create all of this data on the vehicle, and now you're actually sharing it with infrastructure planning agencies. You're sharing this with infotainment providers to help understand what kind of entertainment preferences people want in their car when they are actually going on different kinds of rides. So these are now becoming the ability to be able to not just collect data, but actually put it to use and be able to share and monetize it beyond just a single asset at a time is becoming more and more important. So companies that have done well realize that when it comes to these high value, high complexity data streams like the IoT connected products data, particularly telemetry data that's being generated about the product's performance and being streamed in, doesn't just have one single use case. It has multiple modalities where value can be realized in the business. And this is why the value, everybody believes in the value of connected products data and how digital twins and the processes and the efficiency gains that are achieved by that. But capturing this value has actually proved very, very challenging. So if you look at some of the stats, over 90%, 95% of companies have found it hard to extract value from these high value data streams, and at the same time struggle with a very important aspect of it, which is how do you govern these data sets in a way that actually not only just protects the data and the confidentiality obligations for a lot of these industries, but also make it more accessible to not just technical users, but also users that are non-technical or business-focused users who are trying to make better decisions based off of the data that is being collected from connected products. So what we found many times when we run into these kind of scenarios and with customers is to, if we look at the approach to how companies have collected IoT data or connected products data, I think that's, a lot of efforts have been made in the industry to improve connectivity, to get the ability to capture the right data, and it keeps on getting better and better. But I think where most companies are missing the mark today is, and struggling to create value, is once you've collected all of the data, how are you going to effectively architect the creation of value from that data? And I think that's where things get very, very complicated. And what we are seeing, some of the root causes for that is, you want to be able to get all of this high value IoT data, but combine it with data from your enterprise systems, data from your ecosystem partners, and that becomes harder and harder, because once you've had the ability to actually bring in this real-time data, you need to stitch together so many different kinds of services, including not just your basic streaming capabilities, but your machine learning and data science abilities, now data engineering, because these data sets are highly complex and need a lot of computer-intensive data engineering tasks. But one of the things that becomes really, really challenging is, even if you look at specifically in the IoT space, a lot of customers tend to resort to time series databases as an absolute requirement for IoT data. Well, honestly, that is also becoming while time series databases are important to the discussion, they are not a foundation where you would build your data strategy. And we've found that as more and more companies kind of take that fragmented approach, IoT data as a result gets more and more siloed and duplicated into other data stores, which kind of defeats the purpose of having a single source of truth for this high value data source. Data gets locked in many proprietary formats as a result of having so many different stacks to create value from all of these disparate data sources. And it requires a lot of niche skills that you need to keep training different stakeholders, different teams on. And then you're trying to, for every new use case, you're trying to stitch together a very customized way of putting services together. And then as you keep building use case after use case, things get so much more complex when it comes to security and governance, because then you have to go manage the cost of extra tooling and extra integrations every time you build a new use case. Which is where I think Databricks has a very, very different approach towards simplifying and providing a scale foundation that reduces the barrier to innovation by an order of magnitude. So if you look at what we've done as a company, we started and we were the pioneers of what we call the data lakehouse. So the data lakehouse by itself allows you to have a very simple, abstracted view of how you would interact with your data sets, regardless of what kind of data it is, whether it's IoT data or data neatly structured in tables from your enterprise applications in rows and columns. Everything between unstructured and structured data, it's treated the same way in Databricks, which is one of the beauties of the data lakehouse architectures, which we pioneered. On top of that, we've added a governance layer, which allows you to manage the security and governance and the compliance related aspects of these data assets, not just for data, but also for the AI assets that you're training on top of these high value data streams. Generative AI has been an excellent addition to our platform as a result of our acquisition of Mosaic ML, which has been leader and pioneer in this space. And now we've taken that technology and built it completely inside the platform so that people can natively go build, train, fine-tune, pre-train all generative AI applications inside of the platform, just as they would any other AI model. So if you look at the entirety of all of these components and how they come together, they really provide a scaled foundation for you to not just do this for a small proof of concept, not just monetize connected product data and set up digital twin analytics and data to power your digital twin activities for a set of assets, but to be doing it at scale. And that helps, and the simplification of the architecture really helps drive down costs and accelerate innovation by an order of magnitude. So if you look at the intelligence platform, all of the services that you would need in terms of to be able to deliver all of these use cases on the right are provided in a fully integrated platform versus having to stitch together many different individual services for every use case. And now we're taking the application of generative AI one step further and answer that really hard question of, hey, at the end of the day, if there are field issues or quality issues in the field, data engineers are going to help support that problem. But at the end of the day, decisions are made in the business units, right? So how can we take the power of data and AI and really unleash generative AI in the enterprise and democratize these data and AI capabilities, not just with technical users, but actual business users? So finance, operations, marketing, customer service, after sales. These are the folks who are actually using data to make better data-driven decisions. And this is what we have infused. This is one of the results of our investments in Mosaic ML, is now we're able to take generative AI to continuously learn the structure of your data and provide natural language interfaces to these business users who may not know how to write Python or SQL queries in the most optimized way, but can now interact with their data through a natural language chat style interface, which is what most companies are moving towards given the advent of ChatGPT and Perplexity that people are using in their daily lives. So one thing I would like to do a couple more things before I hand this to Martin to cover some of the content around some real world success stories of this approach is we understand that Databricks is not going to be the only tool in your stack. And that's been very important to the strategy of the company, is to be an open foundation for your data strategy. So regardless of what other tools you're using for data ingestion, for telemetry brokers, and for bringing in data from IT applications, Databricks provides integrations into all of these layers and different technology components that you need to bring together to be able to deliver the work that you're trying to do to help enable your strategy. And this is something we deliver at scale for over 12,000 customers in almost every industry virtually that you can think of. And this is why a number of technology leaders across different sub-verticals, whether it's in the automotive, in the interest of time, I'm going to skip that because I think these slides will be shared with you afterwards. Really love to hand it over to Martin to go through some of the content around the real world case study with the companies that he's been working with. But before I do that, one call out here is, in order for you to start your journey in Databricks, my team is responsible for developing what we call solution accelerators, which are pre-built solutions for priority use cases that help you understand which Databricks technology components can be used to go deliver some of these repeatable use cases that we're seeing in every industry. And we are able to do that because we're at the forefront and leading edge of AI in the world. Just given the work we do, we understand the data challenges, we understand the key components that need to be stitched together to bring these use cases to life. So whether it's in the supply chain space, whether it's in the smart manufacturing space, or in the connected product space, there's a number of pre-built solution accelerators code right there on the bottom right as well. If you're interested in scanning, that'll take you straight to the website. But this is something that's an immensely valuable resource for any customers looking to go deliver these use cases. So without further ado, I'll hand it over to Martin to cover his part. But I would say, if you guys have any questions as we're going through this content, please feel free to utilize the chat and ask the questions, and we'll take these questions at the end because we have about 10 minutes at the end for Q&A. Thank you so much.
Thank you very much, Shiv. My name is Nemcik. I am from DataSentics, expert for manufacturing. And today I will show you and introduce the project that we are delivering with Acond company. This is heat pump manufacturing company.
Over to you, Martin.
Let me introduce on the beginning the DataSentics itself. So we are part of Eviden. So we are startup. We have startup company history, but we are part of Eviden, and we are bringing the machine learning and AI to the client. So we are based in Prague, but we have several other companies included in Eviden part of vertical AI Center of Excellence. The key industry that we are covering is finance, manufacturing, life science, energy and utilities, public sector, retail, and telecom and media. From the data and AI products, we are covering MLOps, generative AI, computer vision, and of course we are a proud partner of Databricks, and we are deploying and delivering AI products. Within our clients are the selected Sanofi, Coca-Cola, as loyal buyer, but we have another one that are under the NDA, mostly automotive company and etc. I am from manufacturing tribe. I'm responsible for pre-sales and product development lead. And in manufacturing tribe, we are not focusing only for the production itself, the shop floor data. We are checking the quality of the product, fault detections, predictive maintenance. This is the main focus of us. But we are speaking also with other departments as engineering, R&D, sales, marketing, IT departments, the building the platform together, and finance, back office, supply chains, and logistics. This is the area that we are covering in manufacturing tribe. And we have another tribe covering the other finance and the industry that I mentioned before. The main format, main framework that we are dealing with and speaking usually with the clients, with the customer, is this framework, Factory 360. It's the framework for Industry 4.0. On the left side, there are all type of data that you can imagine. So basically shop floor data, there are IoT data, sensor data, and structured and unstructured. So should be also video and images. And these data are ingested to the platform as well as enterprise data. So we are integrating this SIP data from enterprise, and last but not least, also not digitalized data, so images and any other type of data. In the middle, we have the platform. Usually and most low, we have a Databricks platform that we are building the data lakehouse, and on the top, we are delivering the use cases in manufacturing area. And the most discusses and delivered use cases are quality inspection, yield optimization, predictive maintenance, and demand forecasting. So today I will mostly speaking about predictive maintenance, but there are others accelerators that we are covering and delivering to the clients. What we are doing with the data itself, it's visualization, but it's not enough just to visualize data, but it's nice to see. But what we are doing is insights. So we see the relationship between the data, and we predict some data, we do anomaly detection, and etc. And in some cases, we are doing an end-to-end delivery. So we have an edge device, and we do magic with the data, the AI and machine learning. And we are doing also the feedback loop. So we are controlling the edge device. And this will be the case that I will present today. Let's go to the case study that I will speak about, and the name is Digital Twin for heat pump. So the Acond company, this is Czech manufacturing of heat pump, and they are brave enough to working with AI. So I have experienced that other companies are not yet started working with AI, and I think it's a pity. And we are lucky enough to have this client because we are close cooperation and we are part of the development now and research together. And they are subject expert in heat pumps and we are subject expert in AI. So together we are building and delivering cutting edge efficiency of the heat pump itself. From the numbers, there are 30 million data daily, so you can imagine how many data are receiving the platform itself and processing. And currently it's connected 10,000 or 12,000 heat pumps, but this will be increasing. And also the Acond is providing OEM for another countries, so it will be increasing also for like white label heat pumps. And we will include the project in this, or spread this project for this OEM also connected heat pumps. From the result that we have, we currently can say that we spend 15 minutes time of the service, so it's becoming more and more efficient in maintenance and servicing the heat pumps itself. And recently, we are proud to deliver the Eco AI mode. So this means then that we are increasing the efficiency using machine learning algorithms for the heat pump. Let's go deeper. So the project will start last summer, and we were able to deliver first use case. It was anomaly detection in beginning of this year. So development took 5 months from the scratch. So from the building of platform and detecting anomaly direction to deliver predictive maintenance. Another use case that we are developing is Eco AI mode, and last but not least is chatbot that increase the efficiency of the service desk. This is the basic, and we have the edge device that are sending the data to the platform, and we built the machine learning model, and we are using it for online monitoring. What we had to overcome as a challenges, of course, we need data to analyze and do the digital twin model. Then we have to build a data platform, and we use Azure as a cloud and Databricks as a technology that provides us possibility to do machine learning. From the client side and from customer, it's necessary to have optimization for the cloud cost. Otherwise, it will be not profitable and we will not deliver this project. So we have to also think about it and calculate together with the Acond business case. And from the security point of view, the clients, the final users are very sensitive to the data from the houses. So we have to ensure the end-to-end security for it. As I mentioned before, the Factory 360, this is framework that we are working with. This is business architecture and concrete implementation of this one. On the left side, we have the data. So we have a data from the heat pump, from the houses. And most recently, we will add the solar panels as a complex model of the house itself, and extending the project for the buildings. So it's not only one house, but it's like complex of houses to have one heat pumps a little bit bigger. From the external sources that we are adding, it's weather forecast and energy price forecast. In the middle, we have the platform, we have a data lake house, and there are stored and calculated the models. So we have implemented envelopes, and we do processing and all this necessary stuff to be able to deliver the insights. On the right side, you see variety of clients and the data consumers that we are delivering data and insights to. So on the top, we have a client. So we have mobile application. They can see and set up the heat pump that they have at home. The use case for maintenance service, they have a service application, and they can consume also the data and insight for the service desk and also for the business itself. So there are variety requirements that we have to fulfill and deliver satisfaction results for this type of clients. Let's go to the use case itself. And the first use case that we delivered was anomaly detection. And as I mentioned, they are expert in heat pumps. We are expert on the data machine learning. And together we came with the equation with the surface where we see on the right side in the picture. And we can say if the values of these three values that are there are close to the surface, the function of the heat pumps is normal. And if not, so we can detect that the heat pump is in malfunction or is close to malfunction. We can alert the maintenance service. And so from this use case, we can in real time monitor the feelings of the heat pump itself and to bring value for predictive maintenance. So how we did it? So we have 3 years, 1 billion of data, and we built the model that you can see on the right side. And this is one of example of this model. And we have on the left side, we have real-time data every 30 milliseconds. We have peak from the edge device that it heat pumps. And this real-time monitoring help us to do alerting for predictive maintenance. This is the summary slide. So as you can see in the picture, this is a real picture from the service desk. They have a monitoring system, and they can connect to every of each heat pumps they have covering, and they have alerting of every of each of the heat pumps. What is bringing as a business value is, of course, reduced downtime, saving of the maintenance cost, increased efficiency. And me personally, as owner of heat pumps, I will appreciate the proactive maintenance. They can call me in advance to say, hey, your heat pumps is going to be malfunction soon, but now it's okay, but I'm going to check, and this reduced downtime, and I'm satisfied as a final customer. This is a really cutting edge that we can provide with this machine learning and anomaly detection. Here's the examples. We are using the Grafana for the maintenance services, and they can see every and each data and historical data in real time for every values that we are able to monitor from the edge device. Yeah. And the next use case, this is my favorite one, and why? Because it's putting the efficiency of heat pumps on the edge. So how we do it? And we have a heat pumps, we have historical data, and from this data we can do model of the house itself. So we can see that their house is on the sunshine side. We know the altitude and the volume and surface of the houses. And this is one of the models that we can extract from the data, and another one is the behavior model. So we can say that it's family with 2 kids, and they have this behavior. So during the weekdays, they're like showering on the evening and etc. So during the weekend, they're outside on the cottage, for example. And from this data, we can do the cutting edge efficiency for modeling of houses, and to set up the heating, set up all parameters to be optimal in the way to save energy and save money on the end. This is the model of the behavior and the house, and also we are including now something that is helping us to be more efficient and more saving, and this is the weather forecast. As you can imagine, we know that it will be sunshine, so we don't need to turn on heating during the morning, because we know that the sun will be increase the heat in the house, and this help us to be more efficient. And also new role will be coming to Czech Republic and Europe, that there will be energy price forecast for 24 hours and every 15 minutes. And this combination of this model is the AI concept that we are delivering to the client. And I can say this is really huge what we are delivering to. He calculates and estimates that will be increase efficiency to compare to common heat pumps about 20%. So you can imagine that savings it's huge. And that, of course, have environmental impact, saving the energy, saving the cost, and also the user satisfaction. What is important also, as I mentioned, the optimization of the cost, it's the calculate of business model. And together with the client, we are also thinking about the subscription mode. And this is something that is new in this area, to have a subscription on the heat pumps. But we are brave enough to deliver this subscription mode, because we are sure that we are a guarantee of saving for the clients and also profit for the company. So this combination, as I mentioned before, the external information model of the houses, model of the behavior of the clients, and combination with energy price, we are sure that we can save money for the final client and also have a profit for us, as I mean for the client account. The last but not least use case that we are currently delivering, of course, anybody is speaking about GPT and chatbot, etc. And it's very nice. So it's very nice that we are able to deliver also this kind of use case for the service desk and for the final clients. And we are combining the technical documentation data from the platform itself, that's it's on the Databricks, and service history and client data. And from this combination, using RAG technology and LLM, we have very good results to be precise with the answer that client is asking, as well as the service desk, because we have two streams. One is for the final client and one is for the service desk, for be more efficient in maintenance. And this will be reducing the time for diagnostic. This is for the maintenance, and to be more and more advanced in helping and overcome the problems that could help with the heat pumps itself. Then what could be beyond? So I was talking about heat pumps till now, but it's not just the heat pumps that we can optimize. From the various of industries that we are dealing with, it should be agriculture, the sensor of watering, for example, healthcare. It should be magnetic resonance devices that we can monitor, do anomaly detection, etc. So for manufacturing, the variety of devices that we can optimize, that we can monitor, that we can do anomaly detection. Also in transportation, logistics, energy. So there are so many assets that can be monitored, to adding online connection to this asset and monitor and save money, save maintenance costs, etc. In terms of smart buildings, there are so many devices that can be optimized, and using machine learning seems to be like enormous saving and enormous increasing efficiency in this case. So there are a variety of the devices that can be optimized, and if you have something in your mind that you can speak with us how to optimize your devices. If you are from the industry, it will be appreciated to contact to be in contact with us, and we can answer the questions. So thank you very much for attention, and if we have some questions, we can answer. So Shiv, do you see some questions you can ask friends? So we have a questions from Michal. So did they make product change based on the output of this for the next step? Yes. So from the beginning we have a discussion about anomaly detection, and we see that the machine learning and AI should be effective for this Eco AI mode. So based on this, that we had a first use case, we go to the workshop and deliver together the idea to have Eco AI mode. So this is the change that they base on this one. So yeah. So next question is from the Ralph. Do you need to retrain your ML models regularly, or training the model is one-time effort? Thank you for the questions. So depends of the season. So we have data from, or we will have data from the winter time and summertime, and for sure the model is totally different because we need to heating and during the winter time and during the summertime, and retrain model is costly. So we have to think on the one hand how much it will be cost, and on the other hand the efficiency. And we estimate that we will select a few groups of the heat pumps, and we will do retrain model on the groups and spread the model for other heat pumps. Okay, other questions. Do you have use case from the actual manufacturing side on your manufacturing businesses? Not aftermarket stuff, but ML functional in production part of the life cycle. Thank you, Michal, for the questions. For sure. So we are delivering the product to many of manufacturing industries, and mostly we are speaking with the not aftermarket but optimization of the production itself. So this is the special use case that I showed today, and mostly what we are delivering is in the production, not the B2B business, not B2C business, but B2B business, and this is included optimization of the production itself. So thank you, Hans, for the questions. It's quite complex, and I'm not sure that I am able to like directly to answer these questions. Can you reformulate this one, please? You are asking about generative AI, how we are using. So mostly are using for the chatbots currently, and yeah. Yeah, there is another questions regarding Mark. Thank you for this. Is there much engineering cost for retraining the model, or is purely computation cost? Yeah, Shiv was already answered, but I can react as well. So if we set up on the beginning envelopes good, so it will be automatically retrain the model, and we just monitor itself. So it will be not necessary to include another engineering or scientist in the project itself. Okay. So thank you very much. I don't see other questions. So do not hesitate to contact us anytime, Shiv or me from DataSentics. You can find us on internet, on LinkedIn, and Shiv on Databricks.com, and there are emails to be able to contact us. So thank you very much. Appreciate to share with you the insight what we are delivering to the clients. Goodbye. Have a nice day.